Okay, thank you, ladies. And on behalf of Jethan and myself at Siemens Digital Industry Software, thank you for allowing us to speak with you today, briefly on the subject of digitalization for the mining industry. And hello from Calgary, where I live out here in Western Canada. It's been about 30 years since I finished my geology degree, and I'm not sure where all those years went, but it's great to get back to my roots and speak with this virtual group of enlightened people who would take it as a compliment when they are told that they have rocks in their head. I don't get to hang out with many people like you anymore. So for years, I've been telling my daughter about how every rock tells a story of what conditions were like when it formed. And I keep hoping that one day I'll get her to look up from her iPad with an inkling of understanding. So we'll see how that goes. Today, I'm going to provide a very high-level view of some of the key concepts you should consider or are already be thinking about regarding the digital twin of your assets, projects, or plants. So next, Jethan. So here we go. At Siemens, we get to work with many asset-intensive industries, and you'd be surprised at how much they have in common in terms of the challenges they face in developing a digital twin that mirrors and supports their physical enterprise. An engineering leader recently told me that my biggest problem is that my data and documents do not accurately represent what I see when I look out that window. Or maybe you're a design engineer and operations maintenance leader who is trying to understand what is happening inside that black box piece of equipment in order to make it work better or remain in service longer. So the subject of digitalization for any mining or processing facility can lead to many different discussions, some of which we show here. It depends on the problem you're trying to solve, the target you're trying to reach, and honestly, the digital realities of your organization. And by that, I'm really referring to the level of, digital maturity within your group or your enterprise, because it varies. My guess is that the organizations dialing in today are all over the map, because that's usually what we find. And more, we believe that in order to effectively digitalize a mining operation, as with most other asset-intensive industries, by the way, taking a life cycle management approach to your capital and operational assets is the best way to build a sustainable foundation to your digital business that you can then build upon to support and innovate your physical assets. Next, Jethan. As we begin, I want to very briefly touch on some of the key global trends in mining as we kick off here. So first, getting access to high quality minerals resources is becoming much more complex. And how we extract those resources is changing too, whether that means going deeper or changing how we operate once we get there. And as with every resource industry, HSSE, which stands for Health, Safety, Security, and the Environment, or what is now more commonly referred to as ESG, for environmental, social, and governance, is a criteria that companies must have a strategy for. And in lockstep with ESG, the regulatory environments are constantly changing and they differ by region, and not staying ahead of them can get very, very expensive. And finally, market dynamics are all over the map and show no signs of consolidating anytime soon, depending on who you talk to. So in general, prices are pretty good now for metals. So the question becomes, how can digitalization help us capture a bigger slice of what's out there? Next, Jethan. So our conversation today is about the digital twin as it relates to mining. This is a very short time slot, but I'd like to take you through a few key points. The first is that there can be different views of a digital twin. First, you have the digital twin of your design. This is what was designed, constructed, and handed over that you started with when you commenced operations. This is often the first wicked problem that an owner-operator has to overcome, and you need to have a strategy to deal with that, preferably before you start the new project, or perhaps you're having a strategy on how to catch up for existing operations, if that's the case. Next, you've got the holistic digital twin of what's really out there as of right now. And we all know that changes as soon as operations commence, so that's easier said than done. And lastly, you have the performance digital twin of your assets, plant, and processes. That's what's really happening out there in and around the pipes and vessels that are in operation. It helps you understand how the digital twin and physical assets can be modeled and then optimized or improved to ensure a higher level of performance. So remember to keep in mind how to develop the digital twin of your enterprise and make sure that it supports what you're really trying to do. There's one other key point that I'd like you to keep in mind, and that's how taking a life cycle approach that ensures the different phases of your project and operations, such as mine design, operations planning, operations engineering, operations execution, and asset management, are all digitally interconnected or they should be. And that information is available to your knowledge workers when they need it and in a way that they can consume it. So with COVID, we've seen that having the technical information supporting your operations locked up in your office, or even worse, in binders in the control room, makes it very hard to access when people can't come to work. Next slide, Jithan. So in summary, it might take some planning to determine how you're going to develop a holistic digital twin of your mining operations, and that will depend on how you're going to use it. Today, it's more important than ever that you have a plan in place to make sure your operations run at peak performance and that your business is highly resilient so that you get through whatever's coming at us. So now we can have a little bit of fun. We always hear from people that people like to see real-life customer examples of how the digital twin was used to solve a problem or help their operations. You'll hopefully remember that the performance digital twin that I mentioned in the last little slide, and the last 2 slides ago. At Siemens, we love to talk about how we can use deep engineering to solve tough problems. So now I'll hand control over to Jithan, and he'll walk you through 2 real-world examples that we thought would appeal to a wide-ranging audience like what we have today. So Jithan, I'll hand it over to you.
Thank you, John. I think you can hear me?
Yep, sound good.
Great. Let me just, let me go to the next slide. Yep. Okay. Hi all, I'm Jithan Tellis. I work for Siemens Canada under Digital Factory Division. Today I'm going to discuss 2 case studies. And at the end, I'll demonstrate simulation of underground mining facility. So let's begin with the first case study. The case study is about the Komatsu Mining division. They provide large equipment for surface and underground mining facilities. Example of this are hybrid shovel, wheel loader, and so on. They have different equipments. This case study focuses on predicting the performance, fuel consumption, and finally a cycle time of large equipment. During the early stages of development, Komatsu used model-based simulation system engineering to represent and simulate entire system in digital environment. What this allowed them? This allowed them to accurately represent control system, subsystem and hydraulic, and as well as electrical system in block diagram fashion, and they were able to simulate. The block diagram shown in the slide here is for the hydraulic system used in hybrid shovel. It contains pump, control valves, and accumulator, and some cylinders. Let's take an example of a dump cycle for this equipment, the hybrid shovel. The dump cylinder is controlled by control valves, and the hydraulic pressure is supplied by the pump. We are interested in right-sizing the components. Also, if required, an additional accumulator, whether it can fit, whether it can hold that much pressure during the duty cycle, or if there is any modification that is required. That's what we are interested in. By simulating different configuration for various cycles, Komatsu was able to reduce time and power required for each cycle. What this led to is increased fuel efficiency of overall equipment. Apart from that, the rigid body representation of the entire structure in 3D environment allowed them to carry out structural simulation such as driveline transmission and rope. They used this model together with the block diagram here. They driven that model using interconnected mode. Finally, our solution has an open interface. By using this open interface, they were able to connect to the external control models such as soil model, power management model, hydraulic control models, and drive the simulation from external model and see trying to match the real life conditions, how it happens in the mining field. To conclude, Komatsu used digital twin and simulation in early stages of development. This resulted in drastic reduction in development cycle. They were able to minimize the risk that were supposed to happen in the future. That happened before. So they reduced that and they increased the vehicle performance. So let me go to next case study. This case study is about a leading American industrial sand supplier. They're based out of Texas. They produce sand and coated sand products, which are used in various industrial and environmental applications. They had old plant, but they wanted to build a new plant efficiently. So the two key challenges that they were facing were increasing the throughput of the facility and reducing the truck delivery time. So to do that, the customer approached us for a new greenfield facility. The data which they presented included plant layout, sand production rate, truck delivery schedule, processing time, and other variables related to the facility. Using this data provided by the customer, a digital twin of the facility was modeled. Once the modeling was completed, a simulation was run on the model using various input parameters, different conditions, for example, truck delivery schedule, the processing time of all equipment, manpower requirement, different conditions. So after that, they got the results. So the results are divided in two phases. The first one is for the greenfield facility, which was not yet open, so it was in the planning stage. Let me go to next slide. So the first stage result was that they were able to increase the throughput by 31% approximately and reduce the truck delivery cycle time by 61%. Now, with this data, they went ahead and commissioned their entire plant. After the commissioning of the new plant, they opened the door for the production. Once the production started, the customers started recording actual time data from the existing facility. And now at this, they mined all the data, fed back the data back into simulation once again to see the deviation from the before, right? And the results were different. They were able to increase the throughput additionally by around 38%. And the cycle time for truck delivery was reduced by 52%. These are not just the benefit. There are other key benefits that I want to quickly highlight. By reducing or eliminating bottlenecks in the line, they were able to increase the productivity of the facility. That was first. Second, by exactly determining the right resources required during the planning stage for the new facility, capital investment was reduced to a great extent. Output of the simulation produced right size inventory, thereby reducing amount of inventory that is required, for example, sand, raw sand and finished sand products. With a 3D layout representation, which helped them to optimize flow dimension, including the buffer sizes. By simulating various what-if scenarios, this is a very important point, they were able to lower the investment risk through early stage. Use of manufacturing resources such as workers were maximized using simulation. To conclude this, all of these benefits are obtained by utilizing a true digital twin representing actual manufacturing condition and a simulation environment. I want to quickly demonstrate underground mining facility. Let me switch my screen. We have a solution to simulate the digital twin. This was built for the one of the Brazilian customer. It's an underground mining facility. So we are here interested in how each resource is utilized at different level. So if there are bottlenecks, how we can eliminate those bottlenecks. If there are other issues which will not surface in the planning stage, we want to take care at the planning stage itself using digital twin. So this model has a multi-level structure. Each level represents multiple resources such as digging equipment, wheel loader, workers, etc. Let's zoom into one of the level. Let me zoom in. So here you can see the different levels and different equipment. So each level has different lines, and there are resources scattered. So I'm going to fire up the simulation. Now, as soon as I fire up the simulation, as per the plan, the workers are moving towards the resources, maybe to dig the minerals, and the minerals are being passed on to the different resources here, as you can see, and they are being processed. For example, maybe a crusher unit, maybe a loader unit, it could be a wheel loader, or it could be a digger, a crusher, any sort of equipment. So now the advantage with the simulation is it's running at the real time scale. I can go ahead and increase the simulation speed just by dragging the cursor. With this, what we can do is 1 year worth of simulation can be done just in 4 or 5 minutes. That's the beauty of the solution, right? So once the simulation is done or it's going on, we can check different parameters. Now, what we can do is we want to visualize how material flow is happening at different level. To do that, I have a tool here available. I'll just say, show me. It shows how material flow is happening. The line segment thickness indicates the material flow density. Thicker the line, more is the material flow. If the line thickness is less, the material flow is less. So by that, we can visualize where the traffic is more, where the traffic is less, whether I need any additional equipment to cater that or to meet the demand. Okay, let me go to next section. So there are various tools that can be utilized to check different parameter. Next parameter I'm going to show you is how we can see each equipment is behaving or utilization of each equipment. So here is a chart. On x-axis, the equipment names are represented. On y-axis, percentage of utilization is represented. Let me take an example of first equipment or resource. That's level 3, line 32. In this, for about 85% of the time, equipment is working, which is shown in green color. Means equipment is fully working. For around 15% of time, the equipment is failed. Whereas, let me go to one more example, level 1 and line 4, which has gray and yellow color. Gray indicates the equipment is waiting for the parts from or the minerals from the next station. And yellow color indicates that it's blocked for the certain time because the next station is not yet done with the processing, and the previous station is still waiting to send that part out of its station. So for around 15% of time, this machine is blocked, whereas for 25% of time, the equipment is waiting for the part. Okay. There are various tools, as I said. We can check the production rate. This is very important. As you can see, we have the ore production rate here. On the x-axis, we have the timestamp. On y-axis, we have ore in terms of tonnage. The unit is 1,000 tons. So there are two levels which we are focusing, level 1 and level 2. As you can see, with the time, rate of production is increasing. Let me go to next. We have a very important tool. It's called bottleneck analyzer. We want to analyze different bottlenecks which are happening in the line, and we want to take appropriate action on it. As you can see, we can have each and individual equipment detail here, how much percentage of time it's working, for how much percentage of time it's failed, how much percentage of time setup is happening, or it's blocked or paused. Different criteria we can get to know. Now, with this, what we can do is, even before we start drilling, we have all this information, we can take corrective action to increase the utilization of the equipment. If required, we can add additional resources to address the bottleneck requirement. If required, we can add additional manpower to have better utilization. With that, let me stop and hand over to John. John, you're there?
Yep, gotcha. Just had to unmute. Thank you very much, Jeethan. That was really good. So, Heather, I think we've got time now for some Q&A. I think we might have chewed into a bit of that, but do we have? I saw some questions coming in down below. So hopefully between Jeethan and I were able to give an answer to those, and anything we can't, we'll get back to you.
And does anybody have any questions? I know Matt already answered one about which software is being used. Oh, we have one here from Cal. What simulator were you using to build, or did you build your own?
Jeethan, I'll let you take that one.
Yeah, this one I've used a plant simulation to build this. It's under Technomatics brand. We have a solution called Plant Simulation. I'll write it in chat box.
Perfect.
Okay, good.
We have another one. There's some belief within the energy industry that digital twins are applicable for greenfield projects only. Can you share your thoughts on how a digital twin could be, oops, it just disappeared my screen, could be used, can be leveraged within a brownfield operation and the type of value that can be realized?
You know, it's a great question, Heather, because starting with a new plant is relatively easy, right? You know, you've got fresh data, you're working with services companies that hopefully are using up-to-date tools, and the requirements for what you require have hopefully been set in the contract. Unfortunately, greenfield projects consume capital, brownfield projects produce revenue, and especially when the economy is in upset mode like what we're in now, whether it's because of commodity prices or any other COVID or whatever, capital projects, there's often less of them, and brownfield facilities hold consistent. So more and more owner operators are looking at extending the life of their brownfield facilities. So question is, where do you start? And often when we talk to owner operators, there's typically a range of sophistication. You can have everything from 100% paper still out there with the change management mechanism as a 3M sticky note, to a fully digitalized production facility that where they have the 3D model, the 2D information. It's being kept up to speed, or as built, as we like to say. The reality is most are in between. And how do they get there? That kind of depends on the customer. We've seen everything from taking laser scans of facilities, bringing them into a centralized environment, and starting to convert that point cloud into intelligent objects that we can then hang attributes and insights off of. We've seen digitizing paper documents and doing optical character recognition to take all of the plant information, let's say paper information, and at least digitizing it to get it into one place, so that we can now start working on it and start cleaning it up. I've seen situations where they take everything they've got and they ship it to a service provider to have it all redrawn in one clean set of drawings to get everything on a consistent standard. So it really depends on the owner's situation and the contractors working with them. I would suggest it depends what their priorities are. What's the challenge you're working with? Are you running into compliance violations because your documentation's up to date? Do you have, hopefully not, but do you have an incident happen in the facility or outside the facility, and you're not able to produce the documentation that shows what you knew or what you ought to have known at a specific point? Have you seen Jeethan's fabulous simulation drawing and saying, I want to do some of that, but my information just isn't at a point where I can do that? Where do I start? It really depends on the priorities. But the technology exists. The problems are that part is already known. We have some great tools at Siemens, and there's other solution providers on the line that I'm sure also have great technologies. So to the owner operators, I would say the best way to get started is to get started. And you'll define what your priorities are, and then the solution exists to help you get there on whatever time frame makes sense for you. Because as a technology industry, if we throw all the science in the world at you, all the technology in the world, that doesn't help, because companies can consume it from at different rates. So not entirely sure I fully answered the question. It depends on how it was asked, but this is absolutely achievable. And if we're going to continue to extract an ROI out of those facilities, maybe longer than they were designed for, digitalization can help you get there. It's a question of developing the strategy that's right for you and your organization.
That's great. I'm sure that's a very thorough answer that will help Emma with her question. We have a number of questions that have come in the meantime, so we might want to see if we can power through a few of them. I'm going to start with someone asked if this was recorded. Yes. I'm not sure if we agreed to, I don't know if we have an agreement yet with John and Jethan, but hopefully we'll be able to share it through our website after the event.
Yes.
And we'll kind of notice that to everybody. So one of the questions from Eli, I think I saw two from you. It was how are the tools integrated with the ERP? And we are developing a project using Team Center. Are the tools presented also in Team Center?
Are the tools represented also in Team Center? So Team Center, so rather than talk about, try to make this brand agnostic for the audience, but every capital project should have a central nervous system. And I like to, sometimes this gets complicated depending on your background. So I think of the system kind of like the human body. The human body is composed of multiple major organs, and they're connected by the central nervous system. And on their own, each does its role pretty well. But the body and a capital project or a mine processing facility is a complex system of systems. And we refer to that class of software as a PLM solution, a lifecycle management solution. We mentioned earlier a capital asset lifecycle management on one of my slides earlier on. Something that connects the various the life cycle phases of the operation. So coming back to the original question, do these sit in Team Center? The solutions that you were talking about are different solutions. Like a simulation solution would be different than your lifecycle management system, but hopefully it integrates with the tool. And our organization has a philosophy of openness and interoperability, so that data needs to move. Data and information needs to pass seamlessly from those major organs that we talked about and connect to the rest of the body in order to be able to accomplish the task that you need to. So I think I answered the question in terms of, is that part of Team Center? No, but I'm using that to reinforce the point that the output of your simulation tools should feed into that central nervous system and be available to other knowledge workers, perhaps elsewhere in different departments, or maybe other assets that you've got around the world, be able to be accessible so that people can continue to benefit them rather than just the runtime of the output. And that doesn't matter whether you're talking about a simulation tool or whether we want to connect our technical information via that central nervous system to the business information that probably already sits in your ERP tool. And by being able to connect that technical information, consolidate it, eliminate the silos as best as we can, and connect that to the business information, now you're really getting the agility to move across the organization. And each of those vital organs, or silos as we sometimes call them, our knowledge workers are crazy smart. They will find a way to connect systems that aren't connected. And usually what happens in the industry is, we stuff those silos, the space in between those silos, we fill up with Excel spreadsheets. And we love our Excel spreadsheets, but you know what? They're uncontrolled. They can be a security risk, and it's really hard to report across them. So, in terms of connecting to ERP, can it be done? Absolutely. Can you do it? There are multiple ways to do it, and it doesn't anymore have to be a major integration project. You can use low-code development or rapid application development to do it. If you basically want to have an app that just takes inputs from source A, source B, brings it onto your phone, connects it, and displays that information in the way that you want to do that without having a PhD in software engineering. Like as we talked about earlier, the tools are there. It's defining what you want to do and then, finding somebody that can help you with that.
Perfect. All right. The next question we have from Leon is there limitations to the plant simulation approach shown? considering the dynamically changing nature of mining operations?
That sounds like a Jithan question.
Yeah. There are some limitation, to be frank, the external models, like sand models or the stone models we cannot have, but we have open interface with the plant simulation, and we can drive this plant simulation from the external tool. It is one of the most open software. You can have like C++ interface, and you can drive the simulation from the different models outside, or different solution, which plant simulation doesn't have a capacity. But to what I have shown in the digital twin, we have built that using the out of the box tools available from the shelf, and yeah, we can pretty quickly build the model. There's no limitation in terms of what I've shown in terms of the resource utilization or the worker utilization. All these factors we can quickly build up. Only thing is external factors where there will be a limitation, but that can be addressed through connecting to a different system and drive the simulation.
Perfect.
Good.
And I think somewhat related as a question from Ton, we have, did you have to build a dedicated data platform, or did you plug all data into the digital twin apps like the simulator?
Yeah, same here again. If I understand his question correctly, do you have to custom build everything, or are you using the out of the box tools? That's the question. Then yes, I've used out of the box available to build this. But when it comes to data specific to mining, for example, the cycle time, the utilization, and different factors, we have imported using the Excel sheet. We can import using different formats, as I said. In this case, we have imported using Excel sheet and fine-tuned the model.
Perfect. There's a question of whether this is in the cloud. Are the solutions in the cloud?
Solution right now, there are different solutions available in cloud. Yeah, this is right now it's not there, the solution, but they're planning to push in coming months.
Okay.
Yeah, a lot of change happening in that space. So some of our applications are up on the cloud. Some of them are, if they're not there, they're coming. So it's an exciting area that stay tuned.
Huh. I like that.
Yeah, just keep in touch with the website. It's a big process. We have a lot of solutions. So, but we're moving there. We think we've got that figured out. It's just a question of finishing it up.
Fantastic. Elliot makes a point, and this is actually good. This is one of the groups that GMG has been talking to. Are people aware of the recently formed Digital Twin Consortium.org? And could this application, create value for the mining industry? So that's out there.
My comment would be I'm not familiar with digitaltwin.org, but I love the stuff. We work with a number of organizations related to that, and I'm going to make a note and have a look at that. So thank you, Elliot, for raising that.
Awesome.
I'm writing it down right now.
Can you please share optimization examples in open pit mining, like how haul trucks, digital twins have helped optimize operations?
Jithan, do you want to try that, or do you want me to take a crack at that?
I'll go ahead. Okay, so truck delivery time, movement, the schedule, these are the concern point, and how much load it can carry. Even before we start our operations, we can calculate all these things in digital environment. For example, my dump truck is going to take this much load, or my loader is going to have this much capacity. With this, if I run for 8-hour shift, this will be the amount I'll be transferring, so and so. With this in mind, including schedule, the truck delivery time, the speed, all this factor we can feed into a digital twin and see how much throughput we are going to get at the end. Like throughput is in terms of tonnage, maybe thousands of tons, right? So whether I'll be able to meet customer demand or not. If not, what adjustment we have to do. all these things we can do it in digital environment itself, so that buying decision on the equipment side is more sensible, right? Or suitable to that factory. I guess there are two parts of the question, right?
Perfect.
Just an example, open pit mining, like how drug a digital twin where to optimize. Yeah, that's how. So you optimize the number of workers required for it, and number of trucks required, the sizes of the truck. So all of this you decide even before you start drilling, right?
Great.
I think Jethan covered that pretty well. I would add that I've seen examples in our computational fluid dynamics realm where we're modeling particulate flows to understand. Remember in my presentation I talked about that black box, right? Running plants is hard because you spend all the time on the outside of that black box or pipe or vessel trying to understand what's going on inside. And they may not be specific mining examples, but examples where we're trying to model particulate flow inside a vessel to understand either how to make it better, or why is it wearing out the internals, or why is it causing failures. So I would open up to the whole advanced engineering simulation discussion can be applied everywhere, mining and everywhere else. The other element that I would throw out, because it's equally applicable in mining, that if you haven't looked at, you really should, is the field of design space exploration, where we're able to connect mathematical solvers to your existing simulation investments or any other database for that matter, combine the outputs of those to resolve a set of stated requirements. And maybe you've got part of the plant, part of the facility, maybe you produce heavy equipment for the mining sector that you're trying to improve the design on, and we just can't seem to find it out. By setting a defined set of requirements on what the known requirements that you have to adhere to on performance or weight or cost or whatever the parameters may be, and allowing design space exploration engines to run and produce design alternatives that, the longer you let it run, the more computing horsepower to throw at it, you will come up with permutations that were never considered, maybe because previously they weren't manufacturable, they weren't machinable anyways, but now we can 3D print them. So, this whole trend of being able to iterate between advanced simulation, engineering simulation, and design space exploration, combined with what we can do on design and additive manufacturing, is really causing some huge innovations that you're starting to see in other industries. Some of the things that are being accomplished and some of the crazy designs and performance at lightweight or lower cost or smaller size that we just never had before. This is what's going on, and it's equally applicable to the mining space. So if you haven't checked out design space exploration, connecting your simulation outputs, that's a really creative area that there's a lot of innovation, I think, still left on the tree. It's only beginning.
Wonderful. Well, I'd like to say a big thank you to Jethan and John. Terrific presentation. We will be sharing it afterwards. Sarah, you're going to say, John?
Yep. No, I was just going to say, so we put I don't know if we got to all the questions. We put our contact info up here. We're not nobody's hard to find these days, let's face it. We're all on LinkedIn. So if you didn't get your question answered, or you've got something specific for myself or for Jethan or any of the Giza simulation expert on our team, Matt's handling our Canadian business accounts, please connect with us on LinkedIn, and we'd be happy to respond to you. So hopefully that'll help once the presentation's shared.
Perfect.
Or you got your screenshots organized.